So in this video, we'll have a look at how we can get the Lorentz transform that gives us the relative velocities. So we'll start with our same system. We have our happy little spaceman, and we have the rocket ship moving with some velocity u in the x direction relative to that spaceman. And in that reference frame, so from our rocket ship, we have our happy little astronaut that's moving with some velocity v dash relative to our rocket ship. So what we want to find is what this velocity v dash looks like from the point of view of our blue man. So we'll start with our Lorentz transform equations that we derived in the previous video. And we know from our motion that our velocity or our speed is equal to the rate of change of our distance or displacement. So that means that v dash is equal to dx dash dt dash, and in the reference frame of our blue man, velocity is equal to dx dt. So looking at our Lorentz transform equations, we can see that dx dash, is equal to gamma times dx minus u dt. And likewise, our dt dash, is equal to gamma times dt minus u dx on c squared. So when we substitute those equations into our equation for v dash, we get the expression that v dash is equal to dx dt minus u divided by 1 minus u on c squared times dx dt. And we know that dx dt is our velocity in our blue reference frame, and that gives us our Lorentz transform for the velocities. So this equation allows us to find the relative velocities of some object in a reference frame moving with a velocity v relative to another reference frame moving with a different velocity. So on this slide, we just have a summary of all of our Lorentz transform equations. And so below this video, I've given you a question to work through, and underneath I've put the worked solution. I don't doubt, and I don't think that you should doubt, that you can do the maths. The thing to practice is once again going to be the interpretation of the questions, so becoming familiar with the kind of language that's used and what that means.